Hello again. My name is Richard and welcome to my YouTube channel. Today, our discussion will be solving 2018-2019 Valley View University semester examination on Calculus 1. This will be a very interesting engagement, so please be my guest. So as you can see, this is Valley View University Department of Mathematics and Science Education, Sandwich 1 2018-2019 final examination on Calculus 1. And the lecturer was Adu Alfred Asiomi, one of my favorite lecturers. The duration was 3 hours. The examination was actually divided into two sections, Section A and Section B. In the Section A, which carry 40 marks, students are supposed to answer all the questions there, and there are two questions. There in Section B, students are supposed to answer 3 questions out of the possible 5 there, and each question, all the 3 questions carry 60 marks. So before the video end today, we'll solve from question 1 to question 3, and I will indulge you to check part 2 of this video, where we solve from the question 4 to question 7. So come along with me as we start solving these questions one after the other. So before we start solving, please, did you subscribe to my YouTube channel yet? If no, please do. It is the only way you can help me grow my YouTube channel so that I can record more mathematical content with you. Now the first question says, find the first derivative of the following functions. And one of them was y equal to the square root of x minus 1 all over the square root of x plus 1. So how do we solve it? So remember, when we are confronted with a function that involves a fraction or a ratio, the rule we have to use is what? Is quotient rule. So we have to use quotient rule to solve this. So we can rewrite this function as y equal to x minus 1 exponent half over x plus 1 exponent half. So we let u to be equal to the numerator, which is x minus 1 exponent half, and v to be equal to the denominator, x plus 1 exponent half. Now what do? We differentiate this function with respect to x. Our du over dx. Remember, we have to use chain rule to differentiate this. Check out my videos on how to differentiate directly with or functions involving chain rule. So we drop the exponent, differentiate the base. So when we differentiate this, we'll get 1. We repeat the base again. Then we subtract 1 from the exponent. When we subtract 1 from half, we get negative half. Then we differentiate this one to find dv over dx. The same thing. What do? We drop the exponent half. We differentiate the base. That will be 1. We repeat the base again and subtract 1 from the exponent. We get negative half. So we can repolish this. Our du over dx will be equal to, we can drop down this because it's negative using indices. So we have 1 over 2x minus 1 exponent half. It will be positive now. The same way, our dv over dx will be equal to 1 over 2x plus 1 exponent half. Now, remember from quotient rule, our dy over dx will be equal to v du over dx minus u dv over dx all over v square. So remember, we had our u and du over dx. We have our v to be this and dv over dx to be that. We just substitute and simplify to get our first derivative. So what's our v? V is x plus 1 exponent half times du over dx. Du over dx is 1 over 2x minus 1 exponent half minus u, which is x minus 1 exponent half times dv over dx, which is 1 over 2x plus 1 exponent half all over v square And what's our v? Our v is x plus 1 exponent half. So we'll have x plus 1 exponent half all square. So we can rewrite the top and polish it very well to look like x plus 1 exponent half over 2 x minus 1 exponent half minus x minus 1 exponent half all over 2 x plus 1 exponent half, then over our v square, which will have x plus 1 exponent half times 2 using indices. So what do? We find the LCM here, then we simplify the top. Remember this half times 2 will give you 1, so we'll be left with x plus 1. So we'll find the LCM of this and this. That will be, the LCM will be 2 x minus 1 exponent half, then x plus 1 exponent half. Now if this divide this, we'll be left with x plus 1 exponent half. So it will multiply this x plus 1 exponent half. So we'll have x plus 1 exponent half times x plus 1 exponent half. Then minus our x minus 1 exponent half. Then if this divide this, it will be left with this. So it will multiply this. So times x minus 1 exponent half all over our x plus 1. So this is indices. Remember, when two indices are multiplying, the bases are the same, we just add the exponent. So we have x plus 1 exponent half plus half minus x minus 1 exponent half plus half all over 2 x minus 1 exponent half, then x plus 1 exponent half over x plus 1. So remember, when half is added to half, it will be 1. And x plus 1 exponent half, exponent 1 will just be x plus 1. So we'll be left with x plus 1 minus x minus 1 for these two, all over 2 x minus 1 exponent half times x plus 1 exponent half over x plus 1. So I'll simplify the top. We'll have x plus 1 minus x plus 1 all over 2 x minus 1 exponent half, then x plus 1 exponent half. Then this, I can rewrite it as divided by x plus 1 over 1. So what will I have at the top here? X minus x is 0. So 1 plus 1 will give us 2. So I have 2 all over 2 x minus 1 exponent half x plus 1 exponent half times, I will reciprocate this, 1 over x plus 1. Remember, this x plus 1 is exponent 1. So when I rewrite these two multiply 1, we'll get 2 over, this is also multiplying this, so we'll get 2 bracket x minus 1 exponent half x plus 1 exponent half, then times our x plus 1 exponent 1. Remember, these are indices with the same base. When they are multiplying, we just add the exponent. And these two can divide by 2. So the numerator there will be 1. So we have 1 all over x minus 1 exponent half. Then 1 half plus 1 will give it 3 over 2. So we have x plus 1 exponent 3 out of 2. So we can rewrite this as 1 all over, remember, this will be the square root of x minus 1, then times the square root of x plus 1. Okay. Then this becomes our dy over dx. I hope you get that. So the first aspect of the question 1 was actually 10 marks. That shows how long it is. This is the second one. We should find the first derivative of this function. Y equal to the square root of t, then another bracket, the square root of t plus 1. So remember, when two functions are multiplying, we use what is called product rule. So we can rewrite this function as y equal to t exponent half times t plus 1 exponent half. So we use product rule. We let u to be equal to the first function, t exponent half, then let v to be equal to the second function, t plus 1 exponent half. Now we differentiate this function. Remember, our du over dt will be half. We drop the exponent and subtract 1 from it. We'll get negative half. Our dv over dt, we have to use chain rule here. We drop, we differentiate this, we get 1. We repeat the base again and subtract 1 from the exponent. We get negative half. We can repolish this function. So our du over dt will be equal to 1 over 2 t exponent half using indices. Then our dv over dt will be equal to 1 over 2 t plus 1 exponent half. Now, remember, from product rule, our dy over dt will be equal to v du over dt plus u dv over dt. So now we know v, we know du over dt, we know u, we know dv over dt. We just substitute, simplify to get our first derivative. So now in substituting, our dy over dt will be equal to v. What's our v? Our v is t plus 1 exponent. And our du over dt is 1 over 2 times t exponent half plus, what's our u? Our u is t exponent half times dv over dt, which is 1 over 2 times t plus 1 exponent half. Now we can repolish this to look like t plus 1 exponent half over 2t exponent half plus t exponent half over 2 times t plus 1 exponent half. So we'll find the LCM here and simplify. So the LCM will be 2 t exponent half, then t plus 1 exponent half. Now if this divides this, we'll be left with t plus 1 exponent half. It will multiply this t plus 1 exponent half. So we'll have t plus 1 exponent half times t plus 1 exponent half plus, if this divides this, it will end with t exponent half. It will multiply this t exponent half. So we have t exponent half times t exponent half. Remember, these are indices with the same base. We just add the exponent. So we have t plus 1 exponent half plus half plus t exponent half plus half all over 2t exponent half, then t plus 1 exponent half. Remember, when half is added to half, we'll get 1, and t plus 1 exponent 1 will be t plus 1. So we'll be left with t plus 1 here, then this one too will be t over 2t exponent half, then t plus 1 exponent half. We'll simplify this. T plus t will give us 2t, then plus our 1 over 2. Then this t exponent half can be written as the square root of t. Then the t plus 1 exponent half can also be written as the square root of t plus 1. So we can conclude that our dy over dt is equal to 2t plus 1 all over 2 the square root of t times the square root of t plus 1. This actually is 7 marks question. The last one, which is the third aspect or the C aspect of question 1, is 3 marks. So the C aspect of question 1, which is worth 3 marks, say if y is equal to e exponent ln x, find dy over dx or the first derivative. See, anytime the ln function meet the exponential function, it's nothing but the value there. So if we have e exponent ln 2, the answer is nothing but 2. I hope you get that. So if y is equal to e exponent ln x, then we can say y is equal to x. Then we'll find dy over dx. dy over dx will be nothing but 1. This is very easy one. So the second aspect, or the question 2 aspect of the section A, is say find dy over dx if y is equal to x exponent sin x, worth 7 mark. If y is equal to ln into bracket sec x plus tan x, also 7 marks. And y is equal to the square root of tan x, which is worth 6 marks. So how do we solve this? The first one, if y is equal to x exponent sin x, how do we solve this? We need to find ln of both sides for this function. So we have ln y equal to ln x exponent sin x. Remember, we can drop off this. So we have ln y is equal to sin x ln x. So how do we solve this? We have ln 1, we differentiate, we have 1 over y. Because y is the dependent, we attach the derivative to it. Remember that. And to be equal to, we use product to differentiate this. We keep sin x, differentiate ln x. Then we keep ln x now and differentiate sin x. That's how we are going to go by it. So when we differentiate sin x, we get cos x. Then we keep the ln x plus. Now we keep sin x and differentiate ln x. So we have sin x times 1 over x. When we differentiate ln x, we get 1 over x. So when we polish this, we have 1 over y. dy over dx is equal to cos x ln x plus sin x over x. So we can multiply both sides by y. Here also by y. So this y can divide that y. We'll be left with dy over dx equal to y into bracket cos x ln x plus sin x over x. Now remember our y is equal to x exponent sin x. We just substitute, then find our dy over dx. So we can say our dy over dx is equal to x exponent sin x bracket cos x ln x plus sin x all over x. Then that becomes our dy over dx. The next one is this. Y equal to ln sec x plus tan x. So the second one, which is y equal to ln bracket sec x plus tan x. Remember when we are differentiating ln functions, what do? We reciprocate the function and differentiate it to multiply. So that's how we do it. So we can say our dy over dx will be equal to the reciprocal of this. So we say 1 over sec x plus tan x, then times. Now we differentiate this and use it to multiply. When we differentiate sec x, we'll get sec x tan x. Remember that. Plus, now when we differentiate tan x, we get sec square x. So I want to simplify this further. our dy over dx will be equal to sec x tan x plus sec square x over sec s plus tan x. Now what's common? At the numerator, sec s is common, so we can bring it out. Sec s out, we'll be left with tan x plus sec s all over sec s plus tan x. So we can rewrite this as sec s plus tan x. So we have sec s bracket sec s plus tan x all over sec s plus tan x. So we can say this can divide that. So our dy over dx will be nothing but sec s. So the last aspect of the question 2, which is worth 6 marks, is y is equal to the square root of tan x. Remember, we can rewrite this as y is equal to tan exponent half x. So how do we do this? We use chain rule to solve this. So we let u to be equal to tan x. Then our y will be equal to u exponent half. Remember, the tan x is u. So in place of tan x, we substitute u. Now differentiate these two functions. Our du over dx, remember, will be sec square x. Then our dy over du will be, we drop half and subtract 1 from the exponent, which will be negative half. On re-polish this, we get 1 over 2u exponent half, which can be rewritten as 1 over 2 the square root of u. So now from chain rule, we can say that our dy over dx will be equal to the product of these two functions. That's du over dx times dy over du. Remember, chain. The du will divide the du, then we'll have our dy over dx back. What's our du over dx? That's sec square x. So sec square x times our dy over du is 1 over 2 the square root of u. So 1 over 2 the square root of u. When we polish this further, we get sec square x all over 2 the square root of u. Remember, this is our dy over dx. However, we know u. What's u? U is tan x, so we substitute. Then we can say that our dy over dx is sec square x all over 2 the square root of tan x. I hope you get that. So we'll end it here today. Please check out my video on section B of this, where we'll solve the question 3 to question 7. Until we meet again, remember to subscribe to my YouTube channel to grow it. My name is Tete J. Richard.